Austin Energy's Cameron Freberg talks about meeting community sustainability goals and the importance of integrating new sources of energy storage with the electric grid. Through Austin Shines, a project funded with $4.3 million from the Department of Energy and another $1 million from the Texas Commission on Environmental Quality, the utility company tested integration of residential, commercial, and utility-scale batteries with the goal of learning about the challenges and opportunities of implementing real-time energy controls across numerous distributed energy resources.
So starting in 2016, we got a federal grant from the U.S. Department of Energy called Shines. The main focus that we had was with the kind of aggressive local solar goals that we already had in place was energy storage. So how do we, kind of tame that intermittency that will come with those aggressive solar goals? How do we do it more affordably? How do we make it more intelligent, not subject just to, the intermittency of how renewables are produced sometimes? So when we were talking about integrating solar with energy storage, it wasn't necessarily just one application of it. We wanted to look at kind of a holistic approach. So with the assumption that the market adoption will pick up on 3 different sectors. So if the residential sector, if, the Tesla Powerwall, the LG Chem batteries, if that sector takes off and there's adoption there, how do we integrate it on the residential level? Same with the commercial sector, the same applications if the commercial sector picks up. And then if we as a utility want to start deploying large grid scale batteries, how do we make those all exist in the same ecosystem? So these are the assets that we actually deployed for. When I mentioned we wanted to do all 3, we put in, a little over 3.5 megawatts all in at these different areas. Probably the most important piece of all this is, especially not only for us as a utility doing a deployment of energy storage, but in the long term, if adoption takes up, how do utilities have an interaction with this hardware or with these assets by having some sort of centralized place for them to live? So our partner, Doosan Grid Tech, had developed the Distributed Energy Resource Optimizer. And again, you'll see DG0 there, that's Doosan Grid Tech 0. And so this is kind of a centralized brain where we can, look at various inputs and controls and start doing real-time controls on these energy storage systems. Initially found 19 different use cases for energy storage that we wanted to test. 19 was way too aggressive as far as what we were going to actually do throughout the duration of this project. So there's 19, but the 6 that you see highlighted there and kind of bolded out in black, those were the 6 where we actually did test throughout this project. The technical feasibility was a big piece of this. Like not only getting those multiple vendors to work together, not only making sure that the communications pathways were open, but how does it connect to that back-end system a utility has? Interoperability, that is, I can't stress that enough as far as the way that the value that comes from an interoperable design, because not only did we do those battery systems from the residential, commercial, and grid scale, I did fail to mention that we did do with our partner in the project Pecan Street Lab a vehicle to grid demonstration as part of this, and then of course things like optimization in developing those operational models for this. How do we want to send signals? Do we want third parties to aggregate it? Do we want to just look at what we think our needs are and do direct control over it? Do we want to make it autonomous? Tons of different applications that could be applied there. Capital costs of these technologies are going to continue to go down. Batteries are going to continue to get denser. So I think that the economics of the actual systems are going to continue to go down. And from an aggregation standpoint, when we talk about economies of scale, is how can you take these 100 or 200, whatever it might be, distributed residential batteries out there and kind of have them act as one unit, maybe 2 or 3 units based on different market signals. And that's really a key, is being able to aggregate a lot of these assets. And one of the lessons learned that I haven't talked about yet, but installing these things, not a simple process. It's not very straightforward. And so there's not a strict permitting structure set up. There's not a lot of codes and standards for installing these at the municipal level, like in a boiler room or something like that. So, or siting these systems in a neighborhood. The amount of outreach that I had / got to do actually for that Mueller battery storage system in a neighborhood was quite significant. So, there's heavy focus on safety, heavy focus on involving your local fire department. A few industry barriers, like right now, like when I mentioned V2G, the project we did, the cost of that two-way direct DC charger in that garage was more expensive than the Nissan Leaf. Obviously, it won't stay that way. And then on the OEM side is just for vehicle to grid or for any kind of outside agency talking to a battery or controlling it, there's obviously warranty issues. Partnership piece is how do we take that we built that ecosystem with about 20 partners in the development of the Shines project, but how do we continue to work with them to, either turn that into large deployments, programmatic things that we can do with our customers. There's there's still quite a few things to do here in Austin with energy storage. Technical feasibility is, still coming. One of the things that utilities are trying to get a grasp on is just the aggregation of electric vehicles in general. Like, how do you create that communications pathway with just EVs, right? So is it through a home charger? Is it through a commercial charger? Is it through the direct vehicles? And I think once that kind of gets figured out, there's obviously a lot of tools that do that right now. So it's getting there. While, I don't think that anyone's doing anything on vehicle to grid mass scale yet, we have over 10,000 electric vehicles here in Austin. So, if you look at that as just battery capacity and batteries on wheels, that's a huge opportunity to take whatever lessons learned from energy storage and translate them to, operating battery systems. We're working on several things here as far at Austin Energy. One's, we have a distributed energy resource roadmap that we're currently kind of building out right now. So we're identifying, well, where do we want to focus our efforts? When we talk about aggregation in large scale, do we want to, if we're going to have a future strategy on energy storage, do we want it to be at the utility scale? Do we want to push customer programs? There's, a lot to figure out with that one as well. And one thing that we do here, it's more from kind of a building codes perspective. We have a fantastic group at Austin Energy called Austin Energy Green Building that focuses on basically standards that go within buildings and, new builds from all three sectors. And there's starting to be pushes for, there's been a lot of push for the renewable piece, but now there's kind of, how do we get those buildings to be more grid friendly to help facilitate that? That's not just from the renewable side, but that's everything from the transportation sector evolving. How do you make those buildings more flexible? And energy storage could be a piece to that. Like, as far as how can you make buildings storage ready, essentially. Now, granted, we don't have codes and stuff like that necessarily, but from a policy perspective, the way that buildings are becoming solar ready, I think you're going to start seeing things like, electric vehicle ready, storage ready, just technology ready.